Welcome, Waco ISD. My name is Dustin Davis, and I'm the Assistant Director at the Greater Waco Advanced Manufacturing Academy. Today we are in our shop to film a segment called How It's Made. Along with me is Mr. Hunt, our precision metal teacher. Mr. Hunt, will you answer a few questions for me?
Sure, go ahead.
Tell me a little bit about your students and your classes.
Well, we have afternoon students right now that are making actual wheels that go on what we're calling a land speeder. We have a body and this is an all aluminum build, and we're taking raw material and machining the wheels. And there's several different steps that we'll take you through and how we are manufacturing the wheels for our land speeder.
So anytime we build something, the very first thing we would ever do is make a blueprint. Tell me a little bit about the blueprinting process.
Correct. Before you begin a project, it's good to have something on paper where you know what the finished product looks like. We started out with just a very rough shop sketch of the ideas, and the students and I worked this together, basically trying to lay out the guidelines on the finished product. We started with 2-inch wheels. We had some 2-inch raw material that comes in a long stick, and we took our saw and sawed it to the appropriate thickness, and then we used our machines, our lathes, to actually face off one side of this material. We were then able to attach it to a spindle that we actually made here in the shop. We took just a piece of 1-inch aluminum and we center drilled it and drilled the hole and used a threading tap to put threads in here. This particular one happens to be a 1/4-20, where we can use our cap head screw and attach our aluminum wheel to the arbor. Then we can attach that to our machine, which we'll show you in just a moment. To actually machine this surface, we can get to both sides and it holds it perpendicular to the machine.
Awesome. Now, I've noticed on your blueprint that you have some measurements. What are some devices that your students use to measure how precise something needs to be?
We have many measuring tools. Some we call precision measuring tools, such as a 6-inch digital caliper. This will actually measure the size of your hair or a piece of paper. This piece of paper is about 3/1000 thick. And so we can get much more precise than what the human eye can actually see. We also have, everybody's familiar with this, it's just a ruler, but it's got lots more marks than a normal ruler you would see. This one actually goes down to 1/32 of an inch. And so we use tools like this to measure different outside diameters, different inside diameters, different thicknesses. We can even use it as a depth gauge to measure the height of something.
That's great. Are there any special projects that you guys do to practice measuring and getting a specific part, from a blueprint?
Yes, we have several what we call performance parts where all the students are required to actually make the same part. We'll start off with just a raw piece of material, and we have blueprints drawn up on the board that give the specification and the location, and we'll use our mill in this case to make a square block, and then it turns out to be a stair step with 1/16 steps.
That's pretty neat. Are there any other projects that your students have done this year leading up to this?
Yes, we've actually had 4 of our students compete at Skills USA. We had district contests located in Waxahachie, Texas, a couple of months ago, where all 4 of our competitors placed state rated. They were able to go to the Corpus Christi state competition just a couple of weeks ago, and of those 4 students, one of our students actually got first place, best blue ribbon in the state competition.
That's great, Mr. Hunt. How about we go ahead and start looking at how some of these parts are made?
Sounds good.
Mr. Hunt, tell us about what's happening at this process.
Okay, right now I've got two of my students that are cutting the raw stock from a longer stock of material. They're measuring from the blade how far it's going to cut where we can be within tolerance when we do the final machining. Mr. Downs right now is tightening the vise that holds the material secure. And now we have Kevin Lambert is starting the machine, and Mr. Downs is introducing the saw blade to the material itself. Okay, so this is the first step when cutting raw material. We're checking to make sure that the cut was done as planned, and there's the raw material that just got cut. That's the first step.
Mr. Hunt, can you tell us what Jacob Kenner from Midway High School is working on now?
Yes, sir. Right now, Jacob is working on step number 2. After we've cut the raw material to size, we deburr it and then put it on the lathe. This is one of 10 machines that we train our students on. And right now, he's going to do what's called a face cut. He's going to cut the front of this part and make it perpendicular to the rotation of the lathe. This process is very important because it's the first fundamental step in building this particular wheel. If we don't cut the wheel straight initially, then the rest of our measurements will be off. And as you can see, he's doing what's called a rough cut. He's taken the material that he needs to remove from the face of the wheel, and the finished cut will be a much finer, lighter cut. Now he's engaged the mechanical feed, and what that does, it allows the cutter to be mechanically fed into the material, giving us a very smooth surface finish.
Mr. Hunt.
Yes, sir.
Please tell us what Mr. Brendan Downs from Waco High is going to do in step 3.
Well, Mr. Downs is going to move the carriage and the cross slide and the other tooling out of the way where we can utilize what's called a tailstop. The tailstop has a Jacob's chuck with what's called a spot drill, and that's what he's sliding into position now. What he's doing is getting the carriage out of the way to where he can utilize the tailstock. And this is a drilling operation where actually the drill is stationary. The only thing that moves is the material. Normally when you use a drill, the drill spins, but in this particular operation, the drill is stationary and only the material spins. So what the student is doing now is introducing the spot drill to the material. And what this does, it drills that center hole exactly in the center. So we are perfectly perpendicular to the part itself. And it's very important in lathe operation. Everything has to be correct and straight or nothing will fit correctly. He's using what's called a peck cycle. He's drilling it a little bit at a time to ensure that he's not melting the material. There's a lot of heat generated anytime you drill a hole, and if you go too fast with aluminum, it'll actually melt the aluminum and will not drill the hole properly. Very good, nice hole.
Good. All right, what's next? Mr. Hunt, can you tell us what's next in the process?
Yes, I can. This is Mr. Lambert, Kevin Lambert from Waco High, and right now he's deburring the part. We've had one side of the wheel has had a face cut done on it, face cut operation. Now he's deburring the part or the wheel where he can reattach it to the chuck, and he will be exactly straight. He's using a parallel placed between the jaws, and now he's loading the part into what we call the jaws of the chuck. Now he's taking the chuck key and he will position this and rotate it clockwise until it tightens on the part. You can tell he's using the parallel to keep him straight and using the chuck key to adjust the pressure to the part itself. We have to be kind of careful at this point. If we over tighten the part, it'll actually crush the part. And obviously if we don't tighten the chuck tight enough, then the part gets loose as we try to cut it, which is not a good thing. So now he's moving the carriage of the lathe down into position. He's using the cross slide, which he's got in his right hand, to adjust the tool that's going to be doing all the cutting. There is a single point cutting tool that we utilize to machine the face of this particular part. As you can tell, our student has got good concentration, he's got good motor control, and that's very important in being a machine operator. You have to be very smooth and very calculated in your movements. It's not something you can do with a large hammer. You have to have a lot of fine motor control.
Mr. Hunt, what's next in the process?
Okay, well, Mr. Jacob now is taking the wheel out of the lathe chuck, and now he's putting it on an arbor that he actually made himself. He took a piece of 1-inch aluminum bar and he cut it to length. He faced off the end of it, center drilled it, and put a 1/4-20 tap threads on the inside of the hole. He's now putting the wheel back into the chuck of the lathe. The reason we're using an arbor is to get the wheel itself off of the lathe itself, at least the lathe chucks. We can machine both sides. We can turn the OD or outside diameter of the wheel to make sure it is the right size for the project that we're working on. The process that he's doing right now is he's setting the lathe up to do a beveled cut. He's going to use the carriage to slide the tooling into position. Now he's using what's called the mitered feed, and what that does, it cuts a particular mitered bevel on the front of that part. So he's through with side number 1, and now what he's doing, he's taking the set screw loose and he's turning the wheel around, reinserting the set screw, and then threading that back onto the arbor where he can do the other side. The operation after this will be to cut the outside diameter of the part, and then we'll do a groove operation in the very center of the wheel. And as you can see, now we're getting closer to the finished product. Jacob's been able to bevel both the front and back side of this wheel. And the next operation will be to put a groove in the center. We're actually putting O-rings that are undersized a bit from that particular dimension, where we can stretch the O-ring over the wheel, and that will give us a rubber tire.
Mr. Hunt, tell me what's going on in this process.
Okay, well right now we've got Mr. Downs again. He's doing one of the final processes using a different tool. We changed out tools from the tool we were using to do a face-off cut and then a bevel cut. Now we're doing a groove in the center of the wheel. That's where the rubber O-ring will fit onto the groove.
About how deep will he make this groove?
He's going for a 1/16 of an inch, which is 62 thousandths.
And this allows the O-ring to stick up and give you a little traction?
Right, this what that does, it captures the O-ring. If you've got a 1/8 of an inch diameter O-ring, then we're making the groove 1/16 or 62 thousandths into the material itself, and that will retain the O-ring and give us a rubber surface to roll on.
So what is Mr. Downs doing now, Mr. Hunt?
He is removing the wheel from the lathe, and we're going to check to see how it came out.
Show them the edges, turn it so you can see the edges.
Nice job.
Mr. Hunt, tell me about the last process in these wheels.
Okay, now we have Kevin Lambert from Waco High School is doing a polishing procedure. We've machined the part, we've checked it for the correct size, we made sure that the wheel was manufactured correctly. Now we want to make it look as good as we can, so we're doing what's called a polish finish on aluminum. We've got a buffing wheel, and you can see he's moving the part back and forth to actually polish the aluminum to a mirror finish.
Thank you, Mr. Hunt, for showing us how a rocket wheel can be made out of raw material. Thank you, students, for showing us how this process is completed on the machines and what you've learned all this year. Thank you for watching WISD TV. We are at GWAMA, where there are learners today and leaders tomorrow.